Assalamualaikum and hi, my name is Muhammad Hazami bin Zahari. So in this video we're gonna present about our finite element method project. In this project we use Pogo stick and this is our group members. For introduction, we can use Autodesk's Nasrang software to analyze the model when it is used by humans. Pogo stick is made up of various parts including spring, slide shaft, pedal, handle and cylinder. For pre-processing step, these components have undergone examination to confirm that the boundary condition, materials, machine type, loading, and other elements of the pre-processing setup for this project are correct. As a result, analyzing this component entails a number of steps, including deciding which tool to use, setting up the material parts, idealizing the parts, producing a mesh from parts, constraining the region, and applying load. So for the first part is spring. You can see here the constraint region and applying load region. This is for slide shaft, for pedal, for handle, and for cylinder. That's all for me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good day to everyone. My name is Haris Nufai Bishamshul Azri and my ID number is MA19138. So as for now, I am going to I am going to present the result and discussion for our project. I'm going to talk about the things that we have examined in this project before the improvement was made. There are three aspects that were analyzed, which is the first one is the displacement, then the stress, and the last one is the strain. The load or the force were applied on the pedal. Then we examine the three aspects after the load was applied. So this is the displacement before the improvisation was made, and the highest displacement in this project is 5.6 times 10 to the power of -7 in millimeter. For the stress, the maximum stress before the improvisation was made is 9.134 times 10 to the power of 4, and the minimum stress is 8.475 times 10 to the power of 4 megapascal. For the last one, the strain before the improvisation was made is 1.615 times 10 to the power of -6 megapascal.
Hello, my name is Muhammad Hadiaki and my metric number is MA19064. What you can see on my slide are our result and we made improvement on design. So what we get are first, which is displacement. We got the result before and after modification. For before modification, minimum is 0 and maximum is equal to 8.94969 exponent -5 meter. For after modification, minimum is same and maximum is equal to 2.88785. So next slide, which is stress. For before modification, we get minimum -4.941 exponent 0.1 and maximum is equal to 4.237 exponent 0.6. So after modification, minimum is equal to -2.7871 exponent 0.6 and maximum is equal to 2.249 exponent 0.6. And for the strain, the minimum and maximum for before modification is before modification minimum is equal to 3.979 equal exponent -8 and maximum equal to 1.237 exponent -4, and after modification minimum 3.576 exponent 0.8 and maximum 5.061 exponent -5. So the result after modification obtains the lowest maximum stress, the lowest maximum strain, and the lowest maximum displacement, while the highest maximum stress, the highest maximum strain, and the highest displacement are before modification. From this result, the analysis can conclude that the most suitable is after modification, because this type can produce few values of maximum stress, strain, and displacement. It has the potential to reduce the total amount of deform in this product. Lastly, which is improvised design of pogo stick. So the first thing that needs to be modified is the slide of the footpad. This is because nearby areas are likely to experience the most deformation when a force is applied when stepped on by a person. So the thickness on the side of the footpad are important in accommodating the weight of person when riding the poker stick. The thickness is made from 20 cm to 30 cm, so a deviation of 10 cm will have a big impact on the pogo stick. So secondly, the sponge will be attached to the pogo stick handle. This is due to the handle low friction coefficient. When this user sweats while playing, it will run down to the handle and cause them to lose their gaps and the handle. The softness on this sponge, which was previously firm and smooth, will make consumer feel comfortable. Consequently, it will boost the safety of everyone using this pogo stick. Lastly, on the edge of the footpad, we have discarded it and it is no longer sharp to step on. So user can just use a pogo stick without wearing shoes. Then we will glue the footpad with rubber so that the impact when the users jump and reach the ground will not feel pain when stepping on it again. So that's all from me. Thank you.
Bismillahirrahmanirrahim and Assalamualaikum. My name is Masita Fitrah and my ID is 19053. In this project, we're going to do the mass convergence. The mass convergence is basically a convergence study to ensure that the model captures system behavior while reducing the solving time. The mass convergence on all projects needs to be performed in order to verify the accuracy of the result. The result of the model must be independent of the mass size. As you can see on the screen, what I'm going to do basically is apply load on the assembly and constraint. And then we will put the mass setting and the total refinement that we're going to do, so, whether easy coarse or more fine, and we set to get the convergent plot. And then we will continue run until we get the convergent plot graph. In the convergent graph, it's going to show the one Mrs. Stress versus the solution step that we're going to see in the result. And as you can see in the screen, we obtain the result and how the product is defined. That's all for me. Thank you.